Hello and welcome. Today we're going to talk about energy transfer. So we'll talk about how sunlight gets to the earth. We'll talk about how air circulates throughout a room. All right, these are all methods of energy transfer that happen in our regular lives. All right, so let's talk directly what happens. So a reminder, energy cannot be created or destroyed. We learned that last chapter. It's simply transformed from one state to another. All right, so chemical changes into motion with biking. All right, radiant or solar energy turns into chemical. All right, photosynthesis. Chemical turns into motion when you burn gasoline in a car, which makes the motor move and the wheels spin. Electrical turns into thermal. All right, in the oven. All right, so one thing that's true, energy stays the same through the energy transformation. So in other words, energy lost is equal to energy gained. However, energy won't fully transfer from one thing to the next, because sometimes energy will be lost to the surrounding environment. So things aren't 100% efficient, but again, if you total up all the energy from the surrounding environment plus the energy that's transferred, it will equal the original energy. Okay, radiation is our first type of energy transfer. This is through electromagnetic energy. I put EM energy for short here. This can travel through solids, liquids, gases, and outer space because it needs no medium. So sunlight's an example of this, visible in UV rays. So again, these are all forms of electromagnetic energy when you talk about radiation. Conduction is a transfer of energy through collision of atoms or molecules. So basically, you guys know in a solid, the molecules and atoms are really close together. They're almost in contact with each other. So what happens, they quickly transfer energy by touching each other, wiggling in place. So solids are really good at this, and metals, because again, atoms and molecules are so close together in those materials. And you guys know pots on the stove, all right, the metal has to be a good conductor of energy, basically, to work well. You don't want to ever use a metal spoon in a boiling hot water, right? Because the heat energy will travel up the boiling spoon, not the boiling spoon, the actual metal spoon, all right, towards your hand and burn it potentially. Okay, so that's why you use a wooden spoon or a silicone spoon, which is more heat proof. All right, convection is a circulation of liquids and gases due to differences in density. So the molecules are heated, they become less dense, and when they become less dense, they rise. And as they cool, they become more dense and sink and fall back down on to the floor. Okay, and that's exactly how a heater works in a room. The warm air rises, goes to the cooler part of the room, sinks, and then goes back to the heater again, and keeps doing that over and over again till the temperature rises in the room. Okay, same thing in your oven. All right, that's why you've heard of a convection oven possibly. Convection oven is just a normal oven, however, it has a fan to speed up the heat transfer, all right, or speed up the convection current that's already there. So it can actually cook food faster. Some people know air fryers. Air fryers are convection ovens. Okay, so you just have a bigger version of it in your regular oven. Some people opt for the smaller countertop air fryer, all right, which isn't as big. All right, now sometimes I don't want to lose energy. Okay, so we have to use what's called insulators. These are materials that do not allow easy transfer of energy. So an example, a cooler. Okay, a cooler is actually meant to keep the heat out, all right, because heat will actually go towards areas that are colder. So when you're putting your drinks in here, obviously the temperature of it is cold, right? Because you got ice and water. Okay, close the top, you're keeping the heat from coming into it and melting the ice. The reverse is true for your house during the winter time. Okay, you're heating up your home. You don't want the heat to go out the window or out the walls of your house, so that's why you have an insulated material if you have very good windows and good insulation in your walls. Okay, so you want to keep the heat in that case. So sometimes we want to keep heat in, sometimes we want to keep heat out, depending on the situation. Okay, heat will always, again, flow from source, which is the warmer area, towards the areas that are colder, which is called the heat sink. So again, if you have the AC on during the summertime, you open the door from outside, the warm air will actually come in. All right, so it's always warm towards cold. You open your fridge door, all right, you go to grab whatever. There's heat going into your fridge. That's why you got to keep it closed, or make sure you close it pretty quickly after grabbing something out of there. You don't want too much heat to get in there. Okay, and then lastly, closed versus open systems. Okay, we want our houses to be closed systems. In a closed system, no energy will be lost. The temperature will become balanced. Okay, so Earth on a whole is really a closed system. It's for the most part on a balance. Okay, we are slowly unbalancing it though with global warming. As an example, all right. But in general, the temperature doesn't change all that much from year to year on the Earth's surface. In an open system, on the other hand, which is most of the case, some energy will be lost to the surrounding environment, and the temperatures will be unbalanced. So the energy lost is not equal to the energy put in. Okay. So an example, these cups right here that are totally exposed, they don't have lids on them or anything, but they do have a metal wire connecting the two cups. Some heat will transfer from the hot to the cold across the metal wires. Okay, but even the metal wires are touching air here. Even if I put a lid on this, you have the metal wires exposed. Some heat energy will be lost to the surrounding air. Okay, so losing that heat energy, again, will make the temperatures at the end of the experiment not be exactly the same. All right, if this were totally enclosed somehow, these two cups would be the same temperature at the end. So in this case, more heat energy is going to be lost from the hot cup than gained by the cold cup. All right, and that's closed versus open systems. All right, and lastly, this picture kind of shows everything all in one. So convection could be the gases that are coming off the fire, so the hot warmth that you feel coming off. Warm air rises, cold air sinks. Here's a metal poker in the fire. That's conduction because it's a metal and solid. That's why they have to wear that heat-proof glove, or otherwise that person would be getting burned pretty badly. And then lastly, electromagnetic energy in the form of infrared, which is heat, and visible light that you can see from the fire. That's radiation. Okay, so just to show you the 3 different energy transfers all in one example. All right, thank you guys for tuning in, and I'll see you next time.